Now I am here with another question of paper 2, that is, it is question number 9. This is a question which is dependent on matrices and also the complex numbers. So let us see here. There are two matrices given in this question, that is S and T, and the product is equal to, here it is A, B, C, D. So I am writing here S, T. I am going to find out, and is it equal to, if it is equal to A, B, C, D, then I will find the values of this A, B, C, D parameters. So I am writing here the matrix S. The matrix S is nothing, 0, -1, and here it is 1, 0. The matrix T is here 1, 1, and 0, 1. This is equal to, here it is A, B, and here it is C, D. We can multiply here. If I am multiplying first row, first column, this is 0 minus, it is this into this, that is 0. This into this, I am writing it is 0 -1. Now what happens? Second row, first column. If it is second row, first column, here it is second row, it is first column. I can say it is 1 into 1, it is 1 plus 0. Then second row, second column, that is 1 plus 0. This is equal to, here it is A, B, and here it is C, D. Now we have to talk about this. This will become equal to 0, correct? This will become equal to -1. This is equal to 1, and this is equal to D. So D. So I am getting A equal to 0, B is equal to -1. Then I can write here it is C is equal to 1 and D is also equal to 1. Like this, I have obtained these values. So we have to see here that is it the option A true or not? So I am going for the option A. What is option A? Option A is here, it is B plus IA, and in the denominator you are having it is D plus IC. That is equal to, here you have to see the RHS, that is equal to I. Is it true or not? Just plug in the values here, substitute the values. What I am getting here, B means it is -1 plus A means it is 0. Denominator it is 1 plus I. That is equal to iota. This is wrong. Why it is wrong? Because the left side is nothing but in the form of 1 plus iota. Whatever you manipulate, you make the denominator as a real quantity. Even then you will not get the numerator as iota, because if I check again here, that is if I write 1 minus iota, then you will get that is nothing but 1 plus 1. So this is becoming real, but it is not equal to iota. Hence I can say A option is the wrong option. Let us go for the next B option. What is this B option? In this we have to see this equation. I am coming to this. So I am writing here it is the B option. In this B option I can say omega. Omega means that is equal to -1 plus iota root 3 by 2. Now we have to write here A omega plus B. So I am writing the value A is equal to 0, 0 omega, and plus here it is -1, that is B is -1. I am substituting here. Then I have to write C and this, that is C is 1, D is 1. So we have to talk about this. What is this? This is equal to omega. So I will say yes. We will check. So I will write here it is, that is -1 and divide by it is minus omega square. I am using the property that 1 plus omega square, that is equal to 0. From that I can get this 1 plus omega. I am writing here. So I can say yes, this is something like this. I have to further simplify. Then I'll write here it is -1 into omega. I am multiplying this numerator and also the multiplying denominator with omega. Again I will be using the property of omega cube is equal to 1. If I use this, this will become equal to minus omega. So now we have to see whether this option B. So B option I have to get actually omega if it is correct, but I am getting here it is -1 minus omega, therefore it is wrong. Let us go for the next, that is the C option. Before going to the C option, I want to finish off this, the D option, the complex number part. That is, I will go for the D option. What is this D option is telling? Z is belonging to H. That is H is nothing but the set of complex numbers. So I will say Z is some complex number. Then I will write this expression A Z plus B, and I am writing here the denominator, it is C Z plus D. It is very clear. Again, the values I have substituted. You will get 0 minus 1 divided by this Z plus 1. Now, when Z is an complex number, definitely I can say that Z plus 1 is a complex number. If it is an belonging to this set H, then definitely this is also belong to H. That is the true option. So I say D option is the true option. Next. Now the question is of the C option. Let us come to this C option. What is happening here? We have to talk about the matrix ST. We have to see that this ST matrix is equal to ST matrix. I will evolve. Just now I have evaluated. I will use it again. What is this one? Here 0, minus 1 and 1, 1. We have to talk about ST square, and we have to talk about ST square, and also it is ST power M. That is, it may be cube, it may be power 4, power 5, etc. It goes on. So we have to find what are the values of M for which this is satisfying. I will say that yes, I will find out first of all what are the powers which is equal to this. To understand that, I will make use of a characteristic equation for this. I will write here, let A be the matrix ST. So if it is ST, then I can say here it is 0, minus 1 and 1, 1. To understand this characteristic equation, I will say yes. Is it satisfying this property or not? We know that yes, characteristic equation will satisfy this. That is A square minus of sum of these two, that is 0 plus 1, that is trace into A, and then you have to write it is plus determinant of A. What is determinant of A? That means this 0 into this minus this. So I will write here it is 0 minus of minus 1 into I identity matrix. So I can very clearly say that A square is equal to, from here I will get A square is equal to, this is A, this is equal to I will write here it is A square will become equal to A minus I. Now I will go for this. I will use this equation repeatedly. I will write this as 1. If I write here it is what is A cube, how to write A cube, then I say simple, apply multiply both sides by A, then we'll say it is A cube is equal to this A square minus A. Now I will write what is A square again. From that equation I am seeing A square is this. So I can write here at the place of A square this one. I substitute here, that is A minus I and again minus A. So I am getting here this is equal to this, and this cancel, this is equal to minus I. Once I get A cube is equal to minus I, it is very clear that A cube, that is A cube is equal to minus I. I can directly jump for A power 6 because I know that minus I square will become I. I can get A power 6. I will write here it is A power 6, that is equal to I. Now in between what are the powers? Let us see this also. So if you want here it is A power 4, then I will write A power 4, that is minus A. Okay. Next I will write what is A power 5. A power 5 means I have to multiply here A. I am getting minus A square. I will use again there. A square means from this equation 1. I can say this is minus of A minus I. This is what I am getting A power 5. That is also not giving me a fruitful result. So A power 6 already I am having. I will go for the next. that is a power 7. So a power 7 is very clear here. If I multiply a, then I will get a power 7, that is equal to a. Now tell me here what happens if I talk about a power 8. Yes. If I say here a power 8, this will become here it is a power 8 is equal to a square. Again, just now we have seen a square. What is a square? A square is nothing but equal to it is a minus I. So a power 8 is not this thing. In the question what is given, it is a multiple of 8. So we can say that a power 8 it is a multiple of so a power 8 and a power 2 we are getting, but we have to see here m is a multiple of 8 or not. So I will see that a square and this one, that is multiple of 8. A means we are writing st power 8 is equal to this st square. Okay, correct. Here m is equal to 8, it is satisfying. I will go for the other options, other possibilities. It is like this. Now I want to go for a power 9. So a power 9 will become equal to a minus I, or I can say a power 9 is nothing but a square into a. If it is a square into a, that is becoming a cube. Oh, so okay, I will write here a minus I by making use of this equation 1 here. I will write here then into a. I am getting here it is a square minus a. Okay. Now I have to further simplify this. So it is something like this. So a square is, again I will write it is a minus I, then minus a. Plus a minus a get cancelled with this. I am getting that is equal to minus I. So a power 9 is also equal to minus I. Okay. Now I will see here what is a power 10. It is minus a, which is very clear from this. If I multiply both sides this a, I will get this one. A power 11, that is equal to minus a square. So that is a square is again a minus I. So I can say that is equal to, we are getting I minus a. Now what will be a power 12? A power 12 will become, by multiplying this, it is a minus a square. Now again I will substitute a square. A square means what here? That is a minus, it is a minus I. So that is you are getting I. Okay, good. Now once again I got it is I. So now I will write here it is a power 12 is equal to I. Now I will write a power 14 will become equal to a square. That means again here I can say it is a power 14 you are getting a square. This will be satisfied. This type of equation will satisfied in this question. So that means here m is equal to 14. Previously what I got the value of m, I wrote here just now. This is here. So m is equal to 8 is there, then m equal to 14 is satisfying. Now very clearly I can say that m is satisfied by 8, 14, and it is not a multiple of 8. So the next value also you can check. You will see that it will be satisfied with another number, that is nothing but something like this. It will satisfy by, after 14, it will satisfy by 20. You can check this. Then I can say that yes, this is not a multiple of 8. Hence you can say that this option is the wrong option. So hence we can say that D option is the correct one, C option is the wrong, and B option is correct, A option is clearly wrong. With this we can say that this is the solution